So in this video we'll just explore a little bit further about how we would deal with a number of forces in vector form and how we'd work out the resultant force and the angle it would make to, say, the I or the J direction. So if I just take three forces to start with, I think 3I plus 2J, 2I minus 5J newtons, and minus 4I plus 7J newtons, and they're going to all act around a particle. So now we have the component parts. If you recall in the previous video I suggested that I would be horizontal, J would be vertical. We can actually add in each of these forces now and look at the overall effect in the I direction, the overall effect in the J. So initially we have 3I and 2J, so we could write that in as that. Then we have 2I and minus 5J, so I'll take the arrow down and call that 5. Then we have minus 4I, so that would be 4 in the opposite direction, and 7J. Now notice how we keep the same nomenclature of right being positive, left being negative. So when I come to actually work out the overall force components here in I and J, it's simply an addition and a subtraction. So in the I components we have 3 plus 2 is 5, take away 4 is just 1I. And in the J we have 2 minus 5 plus 7, which gives us 4J. So my overall force components are 1I and 4J. Now what we can do now is, as they're right angles to each other, the resultant is obviously acting in this direction. A bit of a wonky line, but we know what we're talking about. So there's my resultant. And I can carry out a Pythagorean calculation. So r squared is equal to 4 squared plus 1 squared. So that would give r is equal to the square root of 17, which comes out to be 4.12 newtons. If I wanted to find the angle to the I, or the horizontal as it was, we could use tan theta is opposite over adjacent, so it would be 4 over 1. So theta is the inverse tan of 4. So theta comes out to be 76 degrees. And that's how we would deal with a number of forces in vector form.